All right. Hello, hello, hello. Welcome back, everyone. So, okay, today, this actually started out with this. We're talking about CSS today, right? This started with a conversation that we were having probably in one of our random Friday socials. I don't even remember where we were talking, but Sonder and a couple of other people and I were talking. And Sonder said, because I was going and getting all these experts and bringing them to Angular Nation. And Sonder said, we need help with CSS. He said, go find us someone who's doing cool stuff with CSS, with like JavaScript, and help us do some of that work for us. And so I was actually reaching out to some people because I was just, checking Twitter and finding like some JavaScript and CSS thing. And then Igor Menard, like the same day, the very next day, like read my mind and tweeted that there was this cool thing that he had been watching. And it was like, I just brand new released, I think. And so I said, okay, let's go. So I reached out to this guy, come and talk to us. So I'm going to kick it over to Igor. Igor, can you tell us a little bit about this sprinkles thing and tell us why you're paying attention to it and why you think it's cool?
I can try. So for the longest time, I always felt like I'm an engineer that is really good with TypeScript, JavaScript, making code work, but CSS, it's not my strong part, and I always felt uncomfortable working with CSS, and I felt like I could use more help. And
that's exactly what Sonder said.
Yeah, various technologies popped up, Sass and whatnot, and they're like, yeah, this is better, but it's still not quite it because it just feels so much different compared to JavaScript and TypeScript. The module system, just the way composition works, and all of these things were just like, this is not quite the same as JavaScript. I would like something closer to JavaScript, even better, something closer to TypeScript so that I can have static type checking and IDE auto-completion and those kind of fancy things, and maybe even like optimizations. So statically analyzable code base can be well optimized, so we could do fancy stuff there. But there hasn't been anything out there for a long time until Sprinkles popped up. And I was like, like this checks a lot of my checkboxes. Now, I cannot endorse Sprinkles because I haven't used it. I'm here to learn more about it and see if it really checks all the checkboxes and whether it delivers on the promises it makes.
We're holding on to our skepticism.
Yeah, when I'm curious, but also a little skeptical, because sometimes, when something's too good to be true, it's too good to be true.
So, we can be cautiously optimistic. We're going to have to see it.
Yeah, uncomfortably excited and cautiously optimistic. Yeah. So with that, I think we should just hand it off to Mark. Mark has been in this space for a long time. And Mark, please introduce yourself and show us some magic with Sprinkles.
Awesome. Thanks for that, Igor. Yeah, so as you can see, my name is Mark Dalgleish, and probably most well known for my work co-creating Css Modules, which is obviously taken off a lot more than I expected. I mean, I knew it was one of those ideas that at the time I knew it was a good idea, but I didn't know it would take off the way it did. So yeah, I mean, as a bit of quick background on myself, I've been working in the web for a long time now. Actually, over 20 years, I've been playing around with the web in some fashion, and I would say that I've never been that uncomfortable with CSS. So I'm definitely coming at this from like a CSS native, I'd say, where it's not that I dislike CSS and I'm trying to fix it and I think it's broken. It's more a case, for me, it's more a case of, trying to scale it up to a, design system component library type of environment where you're just trying to make it maintainable at that sort of scale. And the thing is, the tooling has come so far. I mean, sort of to your point, Igor, the tooling has come so far on the JavaScript side. We expect so much from the tooling, particularly with things like TypeScript now, that the CSS, if you just leave it as is, it feels very out of step with what we expect on the other side of that. And so even myself, with the work I've been doing with CSS modules, people were wanting to introduce tooling for type checking of that interface. So I'm importing a style sheet into my JavaScript UI code. I want to be able to have some sort of static type checking that says, okay, the class name that I'm trying to put on this element does actually exist. There's not a typo there. And so people have worked. I've worked on tooling that does that for static CSS. But even then, you start to realize, like, I'm trying to push it even further, and I'm hitting up against the walls of what CSS can kind of natively do for me, or even CSS modules. And so, yeah, I mean, what I want to show you today is, the culmination of years of work in this space with myself and some of my colleagues as well, around, how do we, particularly with TypeScript being part of the equation now, how do we bring type checking into our style sheets? But how do we do it in a way that doesn't sacrifice the architecture that we're used to in terms of, CSS has basically no runtime cost. You're just sending static CSS files to your users. That's often the trade-off other solutions will make. They'll say, in order to create a better developer experience, we're going to move some of that processing into the user's browser, pay a bit of a cost for that. Now, one thing I want to be clear about on that too up front is that, I'm not against that at all. I think it's a trade-off. And in my case, it was probably coming more from maybe a fear that working at the sort of scale that I'm working at a large company with lots of repositories, if we started hitting up against performance issues in this area, it'd be really hard to unwind that. So it was sort of like, well, what can we do that maybe doesn't make that same trade-off? So what I might do is share my screen and do a bit of a demo for what it looks like in practice.
We love demos.
Yeah.
We want to see it.
Now, please, if you want to interrupt at any point and ask a question or whatever, feel free to do that. I won't be offended at all. Let's see. So here's the website on the left here. This is the vanilla-extract.style. Yeah, it's got a bit of a intro to what it is and what it's all about. But the TLDR really is that think of it like a preprocessor. Even though it's written in TypeScript, conceptually, in terms of like the architecture, the way it sits on disk, the way it operates, it's pretty much like a Sass. It just happens to be written in the same, general purpose language that you use in your app. And I think that in and of itself is a huge win, because it means now it solves one of the problems that Igor was getting at before, where you feel like there's this big context switch. I move between my styles and my UI code, my view code, and they're just completely different worlds and completely different languages, and sharing anything between them is really difficult. This gets at some of that problem. What I'm going to do, though, is, actually, I should call out something very quickly, because Igor's been talking about sprinkles, and here I am talking about vanilla extract. They're two different projects. I'll get to sprinkles later. Vanilla extract is kind of like the base layer. That's like your Sass replacement, and sprinkles is more like a framework that's built on top. So you can use vanilla extract without using sprinkles. That's what we use in our work. I work at Seek in Australia. We use that in our work there. So what I've got here is a little app running locally. I will call out, obviously, the elephant in the room. This is an Angular group, but I'm not actually personally an Angular user. My little demo here is using React, but I want to stress that this can work with anything. Like, it's just like CSS modules. So I did try integrating this into Angular, and it was a little more complicated than I thought, and it might not actually work as seamlessly as I thought it would. The nature of the way Angular's sort of hides the build tools away from you and that sort of thing. So might have to do a bit more research there. But in theory, it works with Webpack, so it should be able to be integrated, maybe with some work on our end. But anyway, here's a basic app. What I'm going to do is I'm going to start putting some styles on here. Now, like I said, it's just like your typical preprocessor, where the trade-off is that you have to have a separate file for it. So I'm going to have so I've got my little app here with a header component, and I go into my header, and I want to add some styles to this. So what I'm going to do is here, I'm going to create a new file. I'm going to call it header.css.ts. Is the key thing. So here I'm going to import style from vanilla extract CSS. And then all I have to do is export a style. So I'm going to go export const, let's say background equals style, call this function. And what's cool is this is all type checked. So if I hit control space here, It's actually going to like autocomplete, any CSS stuff I want. Obviously, that's not going to be very efficient for me to just scroll through there. I'm going to say color. Actually, sorry, what am I saying? Background. So background of pink. Okay, cool. So I've created a style called background. And if I go over to my header, from the consuming end, you can think of it like CSS modules, where I'm going to say import star as styles from this file I just created, header.css. Now, the interesting thing, it says header.css. It really is just referencing the TS file. It's just that obviously you don't put .ts at the end of your imports. And what's cool is if I hover over this, actually, it's not telling me what's on there. But if I go into here and I say class name on this heading, styles dot, and there you go. It already knows that background is one of the exports from that file. If there's a typo there, right? If I say background without the D, I'm getting a type error. That doesn't exist on my export. So if I obviously make that correct, hit save, my background should update. There we go. I got my pink background that I just exported from my style sheet. Now, of course, like I said before, there's lots of CSS and JS libraries out there, but the difference here is that this file, because it's a separate file and it's hooked into this Webpack plugin that we have. You can see here, if I go to my Webpack config, I have a vanilla extract plugin here. It's just evaling that file at build time and generating style sheets. So if I view page source here, what you're going to see is a CSS file. If I click into that, there is the styles that I just wrote. And I could go into my JS file, and obviously there's a lot of stuff in here, but what you won't find is any vanilla extract sort of imports or anything. Like, that's all gone. It's all eval at build time. The only thing that gets put into your JavaScript effectively is like the JSON representation of the exports, as you would expect from something like CSS modules. So I'm going to export some more things here. Let's say foreground. Let's call that, what do we say? Color of blue. Why not? I'm going to use the class named library here. See, the imports, auto imports not helping me here. Class names. Oh, that worked. Cool. So I'm going to apply multiple class names here. Files.foreground. Should update. There we go. We got our lovely colors here. I might have some base styles here as well. Say export const root. So you can name these whatever you want. Adding of 24. Let's add that as well. Root. Okay. Let's even this up a bit so I can see the code a bit more. All right, cool. So yeah, again, if I go and look at page source here and I look at my style sheet, you're going to see it's pretty much like what we're looking at over here, but all generated at build time. Now, one thing to note is that at dev time, I get debuggable class names. It's got, header, root. So it's got the file name at the start and then the local name, root, background, foreground. In production, all you get is the hashes. So it's nice and minified. One thing that we pride ourselves on as well, this is maybe going too deep too early, but that's all right. The hash, you'll notice the hash is actually the same every time apart from the last character. This is one of the advantages of doing this statically at build time, is that we can really optimize those hashes because we know, all of these styles belong to this file and we just have a unique hash for that entire file. And then we just increment a counter at the end. So it compresses amazingly well. In fact, you get rewarded the more styles you have in a single file, the better it is for compression. So that really also rewards you for doing like atomic CSS frameworks where you might have dozens and dozens of classes coming from one file. That'll compress amazingly well. Cool. So already I would say, you can see that we're doing a lot better than traditional CSS modules in the sense that I'm getting type checking right out of the box. Usually if you use CSS modules and you want to do type checking, you've got to do some sort of like TypeScript declaration file generation step somewhere in the process. This skips it entirely because you're basically tricking TypeScript. Like TypeScript is just walking those files and it makes perfect sense. We're just intercepting it with the Webpack plugin, evaling it and spitting out static CSS files. Yeah, I don't know how much I'm supposed to keep an eye on the chat here.
It keeps going. Chow was saying it would be cool if it can detect the same styles and apply the same hash to other elements, so you don't have extra CSS.
Yeah, so like one of the, I guess one thing to call out here too is like, because there's lots of trade-offs when it comes to CSS and build tooling. One thing that we've sort of optimized for is the least amount of magic possible, and just try and keep it more like a traditional preprocessor. And if you want to have any optimizations in terms of like sharing things, like in our mind, like that's where like frameworks and things come in, where it's a little more predictable. It's because you can definitely go down the road, I think, with these sorts of things of trying to get too clever, and you end up just this tool that just never ends, just trying to optimize everything all the time. I would say, I mean, there's nothing wrong with that approach necessarily. I think it's more that we're optimizing for our own peace of mind. We can actually step away from the tool and say it's doing its job. It's not trying to do, magic stuff too much. Because even though this is pretty, like, it's pretty cool what it's doing, conceptually, it's not actually that complicated. And that's actually what I like about it. So
Chow approves.
Yeah.
I was trying to get him to come off mute and say hello because he's really cool. We like Chow.
Cool. So yeah, I mean, as I was saying, like this is already, I would say, a big step up over CSS modules, where it's giving you that type checking without any extra steps. You also get, of course, like a preprocessor that is just a general purpose language. I can import any npm package I want with no runtime cost. So again, this is like right now what we're looking at is sort of a replacement for CSS modules plus some sort of TypeScript declaration file generation step, which they do exist. And then it's also a replacement for like a Sass or something like that. But to me, where the power of TypeScript starts to come in is that I can use TypeScript not just between the style sheet and my app code like this. It also means I get type checking within my style sheet, which is particularly valuable, I think, once you start getting into things like CSS variables. So what I'm going to do is show you how we work with CSS variables. What I'm going to do is create a new file, and I'll call it theme.css.ts. I'm going to, if I go to the docs, what I can do is show you, where are we? So if I go to the styling API, I'm going to copy and paste my own docs. If you scroll down a bit here, what you'll see is there's some theming stuff going on here. I'm going to use this one here, create global theme. Well, I'll type it out by hand so you can see. So I go export const vars equals create global theme. And it's global in the sense that I'm not attaching this theme to a class. It's just going to, like, these variables are just going to be available anywhere in my whole app. I do that by attaching it to the root selector. And then what I can do here is I can actually put in some CSS, some values that I want. And I can, what's cool here relative to CSS variables is that I can create an entire tree of tokens. So I can say, like colors, let's give them really boring names, like pink and blue. And we'll go with navy. Cool. And let's add some space here as well. Small. 8 pixels, medium. I can nest this to whatever level I want. I'm just keeping it fairly simple for now. 32 pixels. Cool. So I've created some CSS variables. Right now, they're not being used anywhere. What I'm going to do here is start to replace some of these with some CSS variables. So if I jump back to my app here, so I've got my pink background. I can say vars dot, and it's imported there, dot background. Oh, sorry, no, I called it colors, didn't I? Colors dot, and here we go. I'm getting like auto completion and type checking for my CSS variables as well, in a nested structure too, which is really nice. So I'm saying I want the background to be, what have I got there? Pink. This is not how I would recommend naming your CSS variables, by the way. Obviously, this is just for demo purposes. Same deal here, vars.colors. What was it? Blue. And then here for my space, I could say, vars.space.large that's going to increase a little bit. And there we go. So now if we go look at, what's the output here, you're going to see a similar thing going on where now I've got a bunch of CSS variables being defined at the top. And then here they are being referenced. Again, with the hashing, so CSS Modules famously hashed your classes. With Vanilla Extract, we hash your CSS variables as well. So you can see here, in production, you're just going to get a wall of these hashes with 0, 1, 2, 3, 4 at the end. And it's all, and that means that, of course, that you don't have any global references to these. You have to explicitly import any CSS variables you want to use.
And everything possible to get a couple of those globals if you want to.
Get them to do what? Sorry.
Well, in Angular, we already have like CSS scoping, and it works like similar to what you are showing.
Yeah.
And I would hope that we are able to hook them up together so we can use the Angular hashes instead of the hashes that are coming from Vanilla.js. Yeah,
so there's a couple of things. The first thing is the idea is that for the most, well, if you're just working in your CSS file, you shouldn't need to know the real name. Generally speaking, like at least in our experience, like where you need, or where you would typically want to know the name of it is because you want to do some sort of dynamic runtime theming, where you want to say, like, on this element, I want to be able to swap out a color palette or swap, you're doing some sort of white label app, you're pulling values from the back end. We actually have a specific package called the dynamic package, which is specifically for dealing in this problem. So you can import your CSS variables, but actually what you're really doing is you're importing just the contract so that you know the names of the variables you want to set.
A lookup table, basically.
Yeah. So you can, set individual variables like this on an element, and this just returns an inline style string. So you can, again, it works with any framework or anything that you're just putting a style attribute on an element. And then, so we got two different modes. You can set individual variables on an element. The other one that's really cool is if you want to, this is where the type checking really helps. If you want to implement an entire contract, you can actually pass like a tree of variables, either the whole tree if you want, or some subset of them, and it'll actually type check that and say, like, well, you actually have to provide me a value for everything in this tree, otherwise it's a type error. So that's really useful to like, because that's the sort of thing that's hard, I guess, excuse me, when you're just working with raw CSS variables is, often they form some sort of contract, right? Like you have to implement all of these, 12 variables for the system to work. If you forget one, it's it's a bug, like you've missed something, but nothing's going to yell at you and say you haven't implemented this contract. This fixes that problem for you and says, if you've told me this is the theme that you want to implement at runtime, every value must be provided. Cool. So if I jump back here. So
hey, Mark, we have a question in the chat from Craig, if you have time.
Yes.
In your example, you're exporting a global CSS file and loading index.html. Is it possible to export the generated CSS into JS?
So if I understand that correctly, the way Vanilla Extract works, and part of keeping it simple, is that we generate virtual CSS files, and then we we effectively just hand that to your bundler, and it's up to your bundler to decide what to do with those files. So in my case, if I go back to my Webpack config, that's just like the way I've configured it, is that I'm using the mini CSS extract plugin. So all those virtual CSS files just get collated into the one CSS file and put on disk. What you could do if you want is use something like Style Loader and configure it to actually embed the CSS into your JavaScript files. Like you can do anything that you can do with your bundler. So yeah, it's totally configurable. What's cool, one thing I want to show here as well is one of the limitations I found working with CSS modules myself was often what I'll do is I will want to have some sort of like namespacing, even within a single file. I want to have some sort of namespacing where I've got, here's my collection of, like in this case, I've got my background and foreground. What if I wanted to say, have a couple of background colors to choose from, a couple of foreground colors to choose from, and I want them to be driven by like a prop on the component? I end up having to come up with some just sort of handcrafted namespace so I can separate my backgrounds from my foregrounds. But for when I import that styles object, it's just a flat namespace. There's nothing really physically separating those things from each other. We don't have that limitation here because we have explicit control over what's being exported. To show you what I mean, what I'm going to do is I'm going to turn this background into what we call a collection of style variants. And that's where you get to actually like name different sets of styles. So here I'm going to say my pink background and another one here, say blue. And when I jump back over to my my component, what's cool is that now my background has these two values available, blue and pink. That's obviously a poor choice of color. Let me do it to both here. So I'll say that's going to need to be color. That's style variants. Oh, look at that. So I'm getting type checking. So this is great. Like I'm making mistakes, but TypeScript's making it very clear that I've got typos there. And so we'll say, what was it, like red and so yeah, again, if I jump over to my app, it's gonna, oh, that looks terrible. With pink, it'll look a bit nicer.
Don't try this at home, kids.
Yeah. Yeah, I'm not giving you design tips here, just to be clear. So what's really neat here is that, like, typically, like I said, with CSS modules, you're used to getting a flat namespace out of here, out of this styles object. But now what I actually have is like this tree structure where I've got my root class, I've got a collection of backgrounds, I've got a collection of foregrounds. Where that's really useful, as well as from a type checking perspective, is now I can actually use that as part of the types for the type definition for my component. So let's say for this header, I wanted to have a background prop. I can actually say here that its key of its type is actually from the style sheet itself. I can say the key of type of styles.background. And I'll do the same for the foreground. So that means that if I look at my header props are actually like pink and blue for background, foreground is red and aqua. So if I come down here to the props coming into the component, I've got my background. I can default it to red, let's say, and the foreground. So pink and red, there we go. And then when I come down to here, rather than hard coding what it is, I can say the background is actually coming from the prop and the foreground is coming from the prop here as well. So everything works as expected. But if I come out to my app component, well, I've got this type error here. Just realized, oh, aqua is not one of my colors. See, again, beauty of type checking. I'm forgetting which colors I set up. Well, let's just make it work. Well, there we go. So if I go back to my app, what you'll see here now is that I can say that I want to set the background, and it's all type checked. Now, again, what I want to highlight here is that all the types for this are just being driven off that style sheet. Like, I haven't actually had to sort of manually marshal them through the different layers. I've just defined a set of style variants in my style sheet, and the types just flow through from there. It's really, really nice. And yeah, it's all kind of like driven off the types of everything. In fact, what's cool is that what I could do if I really wanted is I could even say, you know what, I actually just want to have all of my colors from my theme available and type checked. So what I can do is in my header component here, in my header style sheet, what I can do is I can actually pass, here I can say, I'm going to just pass my vars.colors, and then I get a little, the second arg, this is optional, is like a map function to say for each of these what I want to do. What do we call it? Their background. So we're just going to, excuse the typing. What I'm going to do is map that to a background style. I've checked, yes, cool. So what I'm doing is I'm saying for all of my colors, map it to a background style object. And now if I come back to my app here, you'll see all of my CSS vars have now been made available as a prop. I feel like that's the most mind-bending thing I've shown so far. I'm seeing Igor is struggling maybe to get it, which is fair enough.
How does this work?
Well, okay, so the way to think about it, right, is like I'm passing an object here, like vars.colors is an object that looks like this. It's going to have, you know, aqua, and then it's going to have a string of like, you know, theme underscore aqua underscore some hash. Right, and it's all those colors over and over. I won't do it for you. So what I'm doing is I'm passing this object, right? I'm passing that as the first arg, and then there's a map function which is saying, okay, it's giving you the value, which is that this is the hash coming in, like, and I'm saying for each of those, like, turn it into a style object where the CSS variable is the background, is set as the background.
Right. So I get that part, but how do you actually execute this function when you're generating the style sheet, or?
Yeah, yeah, that's right. So what we do is so if I step back, so from a build perspective, what's happening? The Webpack plugin is saying, like, it's keeping an eye out for these CSS-TS files. So the first time you step into this header CSS-TS file, it says, okay, this is actually a vanilla extract file. What we need to do is spin up a child compiler for that, treat that as the entry point, compile that into a JavaScript file that we're going to execute at build time, and then we're effectively just running the file and getting whatever they exported. So if they create CSS variables and then pass them to other functions that then create styles out of them, it all just ultimately ends up in a JSON object that represents like what they've created. And so that means that there's no need for any static analysis trickery or anything that you might expect from some of these other static CSS tools. It can just run the code.
Interesting.
Is there a question? Would it be possible to export a type alias? Yep. They're saying, I guess not. Well, you can actually. So let's do it. So let's say export type background equals key of. I'll just do it in line here. And so then if I go over to my header file, instead of doing that, what I'm going to do is, I guess I've done import star, so I guess it's going to be available as styles.background. Yeah, there we go. Yeah, so you can, I mean, that's the beauty of this system, is that TypeScript has no clue what's going on. Like, TypeScript's just looking at the code statically and going, yep, makes sense what you're doing. And so you can kind of export whatever you want. There is I guess one thing to call out here is one limitation of this system, and I'm going to save your eyes just quickly because I realize you're staring at this horrible red box the whole time I'm talking.
Red and aqua. It's beautiful.
One limitation of this system is that you can effectively only export things that can be serialized as JSON, with a slight caveat, but which I'll maybe get to later. But effectively, you can only export JSON from this file. You can't. So, for example, you can't export like a function because it has to be serialized into something that goes over the bridge. And so, if you start building up functions that have closures and stuff, it's like, what are we even putting on disk at that point? Like, we can't we can't do that. But you can build up whatever deep tree structures you want with whatever JSON values you want, including things that technically have nothing to do with CSS. Like I can say export const foo equals bar, right? I'm just literally exporting a string, and that will work. So I find that's really interesting too. Sometimes where I've landed on this pattern sometimes where I maybe have some constants that I'm using in my style sheet, like the size is, whatever, 12. I can use constants.size inside of my style sheet, but I can also pass it over to my app code and say, well, my app code wants to know the size as well. So let's share some static data between the CSS and the runtime code. So that's interesting as well. So that's probably I guess that's the crux of vanilla extract. Obviously it's a very simple thing I'm showing you in terms of what I'm building, but it scales really well to the size of a full system, with all the static type checking. The fact that you can sort of have these nested files where, I've got one CSS TS file importing another one, sharing variables between them. There was a question before about trying to share code a bit more or that sort of thing. And this is where sprinkles comes in. So I'm going to quickly jump across. So again, the way to think about what we've just seen is that's your preprocessor, right? This is your generic thing that can kind of do whatever you want. This is more about okay, I want to have something to help me build a larger system without generating a lot of style sheets all the time. So the idea with sprinkles is effectively it's like something like Tailwind, where it's what do you call it? Utility first CSS framework, where upfront you define, here are all the common classes that I'm going to use in my app. And often what you'll want as well is responsive classes. I want to set a value just on mobile or set a value just on tablet or desktop. And you just want to be able to quickly and easily do that without having to create new styles to do that or write a new style sheet. So what I'm going to do, well, let me quickly show you in the docs what it looks like if you're using it. Basically what it's all boiling down to is, unlike something like Tailwind, where you're writing a long string of these sort of cryptic class names, you actually write, call this function called atoms, and it's all type safe. So it'll, you pass in the keys and values of the things you want, and it's all going to get type checked for you. But the beauty of the system is you actually get to, you get to completely configure what styles are available in here. Out of the box, it doesn't give you anything. It's up to you to sort of say, these are the classes that I want in my system. We give you something that you can copy and paste to get started. So let's just go with that. What we're going to do is import a couple of functions here. Create atomic styles and create atoms fn. The first one is for defining our atoms. I'm going to define my responsive styles. And so what you'll see here is, well, for one thing, it wants to use space. That's vars.space. There we go. So I'm just going to step through what I've configured so far. Now, again, reminding you that what we're building up to is creating this atoms function that lets us apply the styles. So here we're saying, I'll start with the properties first, because they're probably the main thing to understand first. I'm saying I want to have a class for display none, for display flex, for display block, for display inline. Same for flex direction. I've got a class for row, for column. Justify content. I've got align items. Here I've set my padding top, bottom, left, right. And I've just said, just use all my CSS variables for space. And it's just going to map all those for me. One thing that's neat as well is shorthands. So for example, I want to set the padding to be large. It will actually set padding top, bottom, left, and right classes. It'll just reuse all those low-level classes for me. And the same would be true for, say, margin. So if I copy that, place all those, as easy as that, I now have margin X and margin Y shorthands as well. Now up here, you'll see, why am I getting a type error? What's that about? I might have just made a mistake. I'll back out. All right. Okay, so this is where it gets really interesting as well. So to me, the real power in these utility classes is the fact that it lets you do responsive styles sort of inline. So here what you get to do is you get to define what we call conditions. Now, the reason we call them conditions is because you can actually provide all sorts of different scenarios that you want to target. The most common is going to be media queries, right? You want to say, I want to be able to set display none on desktop, right? Just display none on desktop. So here I'm configuring those conditions. What I'm going to do as well is I'm going to add color in here as well, because that's what we're using in the system at the moment. We'll say background is vars.colors, and we'll say color is vars.colors. Cool. And then once we've got our responsive styles object, we can actually stack up more of them with different conditions, but I'm going to keep it simple. If you scroll down here, what you'll see is that we're going to export our atoms function. We don't have any color styles separately. There's our atoms function and our atoms type as well, which may come in handy later. All right. So what does that let us do? We've basically configured it. Let's actually go and use it. So if we go over to our header CSS file, for example, rather than calling style here, what I'm going to do is call my atoms function. And you'll see that I can say I want padding to be large. That's the same as what I had before. But here's what's really interesting is I can say, actually, I want it to be a responsive value. I want padding to be on mobile. I want it to be small. Tablet, I want it to be medium. And on desktop, I want it to be large. So now if I resize my window, you'll see I'm getting like responsive styles. And what's cool is that like this is just reusing those low level ones. So if I use the same style in 100 places in my app, it's not actually going to create those new styles for me. It's just reusing them. So again, conceptually, the way to think about this is just like Tailwind. Like somewhere in my app, there is a class for padding small on mobile. It's just reusing that class over and over. That's all. And again, what's cool is that this is all type safe, and I get to configure what those classes are. Here's the other thing that's really interesting. So this function, because this function is just gluing strings together, it's actually not creating any styles at all when I'm calling the function, to be clear. Like only the actual setup itself is what it generates all the styles in one hit. From that point on, the atoms function is just gluing strings together of those pre-existing classes. So why that's worth noting is it means that we're not limited to running this function at build time. We can actually use it at runtime as well if we want. So what I'm going to do is jump over to my header component here. And you'll see here I've got styles.root, right? I can actually delete that, and I can, if I want to, grab this atoms function. I'm going to delete this class entirely. Over to my app, and I'm going to inline it. I have to import it. And there we go. So I've actually inlined the exact same styles we had before. So that means that if I'm just reusing atoms, like I might not even need to create a style sheet at all. I'm just going to reuse these low level things. And that's actually true. You'll notice here it's true for the background and foreground, in the sense that what I can do is I could actually say, the types are going to be kind of technically wrong here, but it should still work out. I'm going to say I want the background to be, background, and I want color to be foreground. And that will all still work because it's using my reusable classes that I defined, which if you think about it, what's interesting now is I'm actually not using this style sheet anymore. Like I could literally not import it. And the only thing I'm getting errors for now is like the types. I've said, these types are now wrong. So what I could do instead is I could say, I'm going to use my Atoms type, which I exported before. And I'm going to say its type is Atoms background. And the foreground is my type of Atoms color. There we go. So that means my style sheet, I can just flat out delete it because I'm just reusing my low-level atomic classes that I've set up front. The other thing that's cool about that is, again, without me really having to do any work, we actually now have like responsive colors on our header if we want to. Like I've just inherited that. So I could say, let's say, this is maybe a bit weird, but I can say on mobile, I want it to be pink, but then on desktop, I want it to be blue. And I can do the same for the full, like let's hit save on that. So you'll see it's not going to work. There it is. There it is. I didn't go wide enough. All right. So it's going like I've got responsive colors here, and it's all type checked as well, right? So like if I mistype one of these colors here, I'm going to get a type error. And I can do the same for my foreground color as well. Let's say, what are we? Red and aqua. There we go. I'm not saying this is a good component architecture. This is a very weird API right now, but obviously, you'd build something more. Oh yeah, you want to see the generated CSS, of course. So yeah, if I look at the generated CSS, what you'll see here is these are all the generated classes from Sprinkles that we've configured. So you'll see up front, first of all, there's all of our CSS variables, right? Then we've got display none, flex, block, inline. We've got all of our flex directions. We've got all of our justify contents, all of our align items, all of our paddings, all of our backgrounds, all of our colors, right? And then here's our first condition. Here's tablet, as we've called it. And then it's the same values basically again, but they're just scoped to that viewport size. And then here it is again for 1024. What's worth noting, I guess it's probably the elephant in the room here, is like right now we're shipping a lot of CSS really for no reason. Like we're using a few colors and that's it. We're kind of deliberately making the trade-off that like, first of all, like I said before, this doesn't solve everything, but one thing to keep in mind is this does compress really well because again, in production, you've got this same hash over and over and over again, effectively with one counter incrementing. And then the vars are hashed as well, and it's just a little bit of CSS. So this stuff compresses amazingly well. The other thing as well is that we're sort of banking on the idea that once you get to a certain scale of CSS, there is so much repetition of styles that it's actually worth taking that hit up front, and then you can heavily cache that if you want as well. And it means now you still get all the benefits of, well, most of the benefits, I'd say, of a runtime CSS in JS solution, which is to say, I can have very dynamic styles, right? Like I've got props coming into a component that are changing the styles on the fly. It could be based on user interactions and all sorts of things. But I didn't have to introduce a runtime for my CSS, like to generate that CSS on the fly. It's all just referencing a static set that I've defined up front. The other thing that's cool as well is, one thing that makes this easier as well is if you ever want to optimize, if you say, I feel like I'm shipping a lot of CSS, right? And I don't know if I need it all. What you can do is you can actually leverage the fact that you're using TypeScript and start pulling things out. So for example, do I even need justify content? I don't know why I'm getting these type errors when I change stuff. It seems really strange.
Do you show what happens when you put an issue on the color? Like if you type the wrong color, does the app stop or does it generate the wrong CSS?
If you type the wrong color name, did you say?
Yes.
So what's going to happen is it's just going to resolve to undefined, basically. Like, so TypeScript will say this is invalid. It'll still let me run the. I can obviously show you what happens. So if I go to my app here, let's say I've got a typo here, TypeScript's not happy. Oh, actually, that's right. I forgot we introduced this. We didn't used to do this. We used to just sort of silently fail on this. We decided we should throw errors. Yeah, so it actually gives you a runtime error as well. Yeah, I realize what the error is here. The types are a bit weird sometimes if you just by the nature of this function. I delete justify content, but it's still actually being referenced down here, so I can't use that. That fixes it. So like I'm not using flex direction, I'm not using display, I'm not using align items. But what's cool, right, is like if I get rid of something I'm actually using, let's say background, I'm getting type errors straight away. So it means you can go in and prune the styles, right? Like you can say, like, I'm actually going to go and get rid of things I think I'm not using. And if I happen to remove something that I am using, I'm going to get a type error right away. So that's why we think it's like, this is actually kind of a nice way to do it, which is like it encourages you to create those utilities up front. And I think what the other thing too is, I mean, when it comes to atomic CSS, there's also this whole different way of thinking of like, do you generate atomic styles automatically or do you go utility first? I'm a big believer in utility first because I feel like it encourages you to be really lean with your CSS. Like it encourages you to reach for pre-existing styles and try and come up with a minimal set that you can reuse a lot. That's how we build stuff. And I find it works really well in practice. It encourages you to keep your CSS small over time. What was that? Sorry, can you also inspect the header element in Chrome? Sure.
And while you do that, I just want to jump in, Mark, and let you know we are at the top of the hour. And I'm fascinated with this. So like, I would love to stay here all day and talk to you about this because this is very cool. And the only reason why I'm stressing is because I have another meeting coming up. But I really love this, and I haven't really said much because I'm just very impressed with it. I just really like the way it looks and the way it feels. It just feels intuitive to me, and it's beautiful, and I love it. So, and also because we have more questions, like I feel like we're just getting started on the questions. And I have to wrap this because I have to go. But if you have time, you're more than welcome to stay in this call and chat and nerd out about this as long as you want to, because this is really interesting. And I don't want to break this party up at all. But I do want to stop the recording if that's okay. And then I'm going to leave you guys. But before I do, well, actually, first, do you want to add? Because I don't want to like just stop things abruptly because this is a really cool conversation. So I just want to give it back because I do have a few minutes. Do you want to add anything? And then I'll stop the recording. You guys can stay.
I mean, the only thing I want to add is thank you so much for giving me your time and your attention. I hope this resonates with you. Please do go and check it out. Have a play with it yourself. I think it's one of those things where obviously I'm biased, but I think it really clicks when you start to play around with it.
Absolutely. And I also want to thank Igor for helping me find this because I wasn't even paying any attention to what you were doing. And then I came to meet you because Igor tweeted about you. So thank you, Igor. Thank you, Mark. And again, you guys don't leave because I'm not going to end the call. I'm just going to stop the recording. But before we do, I really want everybody to, you know how we are. We have a tradition here. Everybody come off mute and please let Mark know what you think about this cool new thing he wrote.
Mark, this is great.
Thank you very much, Mark.
Thank you.
Thank you, Mark. As a framework developer, I'm really excited about vanilla extract, and as a person who builds web applications, I think sprinkles are really exciting, and I just can't wait to see people building on top of sprinkles, like design systems that then other people can use. I think that would be really, really cool. So thanks for sharing this with us. This is amazing.
Thank you.
All right. Great call, everybody. Thank you so much. Don't go away. We'll see you next time.
See you. Bye.